Next MCQ, a theoretical MCQ from NEST 2010, question 5. NEST 2010, question 5. We want to determine the value of Planck's constant h by doing an experiment using the photoelectric effect. This experiment is performed by varying both the frequency of the incident light as well as the intensity and measuring both the voltage and the current. In order to calculate h, it would be best to plot current as a function of frequency, current as a function of intensity, stopping potential as a function of intensity, stopping potential as a function of frequency. Well, what is the formula that we know? K max is equal to h nu minus phi, right? H nu minus phi. If we know the metal's work function, we can easily say EV naught is equal to h nu minus phi naught. So which graph seems to be the best one? Stopping potential V naught as a function of frequency. Okay, it would be a straight line, just get the slope, and in fact we have solved a sum of this kind. Okay, we have solved a sum of this kind. Where was that? Yes, in 2021 first shift there was a sum where we have found that out, if you remember this part, right? The options were requiring us to find the value of the Planck's constant, calculated value of the Planck's constant. Got it? Maximum kinetic, yes. So I'll just put this one there, refer to this MCQ. Refer to that MCQ on okay. Refer NEST 2021 second shift, first shift, question 6. Okay? So you've got the option as D, definitely you've got the option as D, but let's also go through the other options. Okay, let's also go through the other options. Let us start with B. Okay, let us start with B. Okay, see in B they're saying current as a function of intensity. Current as a function of intensity, and we know that this is a straight line graph, right? In our textbooks they don't specify the slope of this, but we know that current increases linearly with intensity because current tells us the number of photoelectrons coming out per unit time or reaching the collector plate. And why would that be proportional to intensity? Right, because greater the intensity, greater the number of photons. So B is a linear graph, but we don't know its slope, right? We don't know its slope. So B cannot be considered as a trustworthy way to obtain Planck's constant. Option A, what is option A? In option A they say current as a function of frequency. What do you think? Current as a function of frequency, how would the graph look? Look, suppose this is the threshold frequency. Okay, this is threshold frequency. The graph of the current will look like this. Right? It will be a discontinuous function at nu naught because the current will suddenly become non-zero. And then it will increase with intensity, but it will not change with frequency. Okay? C, stopping potential as a function of intensity. No, stopping potential remains constant with intensity. Right? Stopping potential remains constant with intensity. Stopping potential remains constant with intensity, and provided nu is greater than u naught. Okay? Got it? So we discussed all possibilities now.